variables on both sides. Very important to remember that if this is a plus -1 and you're distributing a -1 to both right here, that gives you -3x and a -5. Remember also a negative is the same thing as a minus. If you don't want to, you don't need to put that plus -5. You can eliminate that and know that it is a -5. 4 plus a -3 plus a -5. Now this on this side of the equation, it's an equation because of the equal sign. But on this side of the equation, we need to make it to 2 terms. There's 1, 2, 3 terms. We want to make it to combine to make 2 terms. That gives you a -1 plus a -3x equals to 4x minus 20. So right now we got 2 terms on both sides. We're good. We need to get rid of the smallest variable. The smallest variable is -3x, so we add 3x to both sides. And that gives you 7x minus 20 equals to a -1. Okay, so you need to get rid of the -20. We want to find out the number we need here to multiply to subtract 20 to get you -1. So you have to add 20, okay? And that gives you a positive 19 equals to 7x. Divide by 7. Remember, I want all numbers answer as a mixed number. So your answer here is 2 and 5/7. Okay? That's our answer, and that's our answer. And this is what I want, equals to x. All right, I need to write smaller. Number 2. Distribute. Oh, this side, look. These are alike, so we can combine like terms, and gives you -7m, that's a plus negative, equals to distribute first, that's a -6m, that's a plus -3, remember, and that's a minus 24, or a plus a -24, whichever way. 7 equals, combine the like terms. Okay, that's a minus m, combine the like terms. I'm going to combine my m first, -6m, and an m gives us -7m. And these two combined, I'm going to use another color so you can see better. These are alike right here. Okay, those are alike. That gives you a -17. Okay, that is equal to a -7m. Okay, now here's where kids get mixed up. Now either we know because these two are alike, when the coefficient, this is called coefficient, are the same. When we get to where we distribute already, we can't combine like terms anymore. When the coefficients are the same, we know it's either infinitely many solution or no solution at all. In this case, obviously, it's going to be no solution because they're not both the same on both sides. But to prove it, you have to add 7m, cancels out. That leaves you 0 here, equals to -17. If you get confused, remember you can always add a 0 there to see that it's really 0 at any time. So this is no solution. Okay, no solution there. Now, this one here, distribute, -1 right here, distribute, that's -3h plus a -7. Okay, that gives you yeah, that's all you can do on that side of the equation. 3h, and this gives you a negative, that's a plus negative 2, so that gives you a plus negative 8h. That gives you a negative 4. Okay, right on this side of the side we need to combine like terms because there's 3 terms. These two are alike right here. That gives you negative 5h plus a negative 4. These little dots annoy me. Okay, and that gives you this side. We know it's one solution. We know it's one solution because the coefficients are different. So because coefficients are already different, we know for sure it's one solution. It doesn't matter what the constant is. Okay, so we have to take the smaller one. The smaller one is a negative 5, so I'm going to add 5 to both sides. That gives me a 2h plus 7 equals to negative 4 minus 7 minus 7. That gives me a negative 11 equals to 2h. Divide by 2, divide by 2. H is equal to a negative 5 and 1/2. Remainder of 1. It goes in 5 times with a remainder of 1. Remember, the remainder is your numerator. Okay? Now number 4. Make an equation that has no solution and an equation that is infinitely many. So we want to make both no solution and infinitely many solution. Explain the difference between the two. So we want to make 2 equations and explain the difference. Okay. So when you're doing this, you start with the ones with the most terms in, and it's that side. You always do one with the most first. So we can put any number in there you want. Whatever it is, you can put whatever you want. Let's say I do 10, 5, and 4. Whatever. So I make 10 minus 5 parentheses 4k minus 4 equals, we're going to leave this alone until we get only 2 terms here. We're going to work on this side first till there's 2 terms only. So we distribute, that's a plus negative. So that's a negative 20k minus or plus 20. And that's equals to 10. We combine the like terms. These two are alike. Okay, that gives us 30. So negative 20k plus 30. Okay, now we can look at equals. Now we can look at this problem here. Okay, that we need in order to be no solution, everything needs to be alike. So for it to be no solution, this has to be negative 20, the coefficient. So that is this part right here. Has to be a negative 20. And this has to be 30 right here. The constant needs to be 30. So therefore that has to be negative 20k minus 30 plus 30. Uh-oh, how do we make it a plus 30? Aha! How do we make it a plus 30? That's an interesting one. It has to be a negative 30. So minus a negative 30 to make it a plus 30. So our missing number here is negative 20 and then negative 30. Okay? So we have then a negative 20k plus 30 to make it equal. So our missing numbers are these. To make this have no infinitely many. This is infinite solution. Now, to make it no solution, let's gonna keep everything the same. We're gonna keep everything the same right here. So it's gonna be negative 20k plus 30 equals, now we need to, for no solution, the coefficient, the number next to the oh, sorry, I meant to put the highlighter. The number next to the variable, the coefficient, has to be the same. So, negative 20, you need to start using these vocabulary words. Negative 20k has to be the same, okay? Then you need to change this, the constant. So it cannot be exactly alike. So we know then for sure, let me erase this, because that started out to be, we need to keep it the same as up here. That's 10 minus 5 parentheses 4k minus 4. So that would be back to our original. We want to make this the same because we want to know the most, the missing number. Okay, so it's that, this, and this. Okay, that gives you the same thing if we solve it, this problem right here. And we need to make it, negative 20k. And it doesn't matter what this number you minus 50, 15, whatever it is. Doesn't matter. It needs to be different. So, what is it? Why does it show up? Okay, so you need to explain that. Explain the difference. I think I wrote it too large between the two. The only difference between the two is what's the same is the coefficients need to be the same. Okay, the coefficient needs to be the same for infinitely and no solution. The only thing that is different is the constant. So they want the different, explain the difference between the two. The constant is the only difference between the two. You need to use the word constant. The constant is the only difference. And you need to explain why. You need to explain that the constant with, I don't have enough room here, the constant with the infinitely many solution are identical, while the constant in, oh my gosh, am I talking too loud? While the constant in no solution has to be different. For example, in this case, how do I get rid of that? Sorry, you guys. I don't know how to get rid of this right here. There you go. The constant, anyways, has to be the same for the infinitely many. For example, in infinite many, the constant was 30 and 30. And when it's no solution, the constants are different. In this case, this side, the constant is 30, just like the other one. Come on. Am I talking too loud? Maybe. Go away. 30, and where the constant on this side is a negative 15. Okay? You have to explain it. I ran out of room because I will ask you on a test. It's a good test questions for me. Okay. 3 waiters at a local restaurant earned different amount of money the past week. Jennifer, we know there's Jennifer, earned $40 less. So Jennifer, different color. Jennifer earned $40 less than Flip. Okay, twice, that's 2 times. Oh, Tony. Okay, there's Tony. So we have Jennifer and Tony. So we're going to put Tony first, and then there's Jennifer. Chris earned, there's Chris. Chris earned $60 more than Tony. Okay, so Chris, $60 more than flip Tony. Okay, so let's look at Tony. We don't have any information on Tony, so Tony gets an X. Jennifer, we know, is $40 less than, we flip, so 40 goes in back. Twice times Tony. Tony, as we say, is an X. Twice times X. Chris earned $60 more than Tony. So Chris is $60 more than makes that go in back. Tony is X. How much did each waiter earn if they earn a total of $900? Okay, so we make Tony plus Jennifer, which is 2x minus 40, and then the last one is Chris, it's x plus 60, okay, and that's equals to $900. Okay, there we go. That gives us combined like terms. These are alike. Gives us 4x. And then these are alike, negative 40 and 60. That gives us $20. Okay, no terms left that we can't combine. We can combine, so that equals to 900. Minus 20, minus 20. That gives us 880 equals to 4x. Divide by 4. X equals to 220. So X belongs to Tony. So Tony makes $220. Jennifer makes 2 times Tony, 220. So that gives you 440 minus $40. Oh, she makes $400. Not bad. Chris is Tony X. $200. 220, sorry. So it's 220 plus the $60, which makes 280. So it looks like Jennifer makes the most. Okay, so Jennifer, Tony, and Chris. Okay, you need to put this in a complete sentence because, and I should have stressed this today in class, how much did each waiter earn if they earn a total of 900? So you need to write, Tony earned $220. Jennifer earned $400, and Chris earned $280. Which total to $900, right? So if we check it, make sure it equals to 900. Okay. Sometimes if our setup is wrong, it still add up, but all our numbers is wrong. So checking sometimes, a lot of times in this problem, depending if your setup is wrong, all your answer will be wrong. So it's really important you get these right here. Extremely important. Okay? Have a great day, and that's what's on here.